Hi guys, so continuing with the A-star playlist that we've been doing in A-level maths, I've picked out two very difficult parts of this question that would definitely trouble most students. So let's give it a look. I've also written out the compound angle formulae because you do have to use them in the beginning of the question, or in the middle of the question actually. It tells you to show that dy dx is equal to cot over half theta. So just a reminder, cot is 1 over tan, so this can alternatively be written as 1 over tan over half theta. We are actually going to use that later on, but for now, let's form an expression for dy dx. Right now, x and y are in terms of theta, so one thing we will be able to find, well, two things actually. We can find dy by d theta by differentiating this right hand side with respect to theta. We can also find dx by d theta by differentiating the right hand side with respect to theta. Let's do both of them and then think about how to combine them to get to dy dx. So the differential of cos is minus sine, but because we're differentiating minus cos, that becomes positive sine theta. The differential of theta is just 1. The differential of sine is just cos, so that's just 1 minus cos theta. So how do we combine dy d theta and dx by d theta to get dy dx? Well, actually, in theory, the d thetas should cancel out. Sorry, I can't talk today. They should cancel out. I'll show you why. So if we write it out like this is the perfect way because diagonally the d thetas will cancel out, leaving you with just dy dx. So let's do that. Dy by d theta, we're going to write that as sine theta, and we're going to multiply onto it d theta by dx. Now what we found is dx d theta, which is 1 minus cos theta. What we want is the reciprocal of that. So we can literally just say that it's 1 over 1 minus cos theta. D theta by dx, that is. Now that we've got both of these variables, we can multiply them together and form an expression for dy dx. We can say sine theta times 1, which is sine theta, all over the denominator. Because remember, when you multiply a non-fractional term with a fraction, you're only multiplying the top of the fraction by that term. Okay, we've come this far, but how do we now show that dy dx, which is equal to all of this, is also equal to cot over half theta? Now this is where I'd advise students to think about what we're trying to get to, sort of play about with it a little bit. So expand it out, see what you want to get to, and then go backwards if that makes sense. For example, we know tan of a half theta is equal to sine of a half theta over cos of a half theta. But what we want is 1 over tan of a half theta. So we can say that what we want is the reciprocal of this is cos of a half theta all over sine of a half theta. So essentially we want to show that the expression that we got for dy dx, all of this is somehow equal to this. How do we do that? Well, think about the angle actually. What we see is that the angle is being halved. Now, what do we know about double angle formulae? I'll show you why this is useful, by the way. We know that sine 2a is what you get when you replace a with, well, a, and b with a as well. So that becomes sine a cos a plus sine a cos a, or 2 sine a cos a. Now, why that's important is, what that tells you is that when this angle here is 2 times a, the angle on the right hand side is half of it. That means that we can still apply that same concept here, even though it's just an angle of theta. We can say that sine theta is equal to sine of a half theta plus a half theta. And then we can use the compound angle formula to expand that out. In a similar way, we can call cos theta 1 minus cos of a half theta plus a half theta. That's what makes this question an A-star level question, honestly, the fact of how unique it is. Because even thinking to do that took quite a while for me to sort of go about thinking about it. Now that you've done that, we can expand it out using the compound angle formula. So this becomes sine of a half theta plus cos of multiplied by cos of a half theta. So let's write that out. Sine of a half theta multiplied by cos of a half theta. And then plus, again, cos of a half theta, sine of a half theta. So they just like terms, they add up to make 2 sine of a half theta, cos of a half theta. Now we have to be pretty careful here, because what we see is that in the answer that we want, there's no constant. So we need to somehow replace this bracket so that there's a 1 inside of the bracket, so that 1 take away the 1 will cancel out that constant. Again, like very outwardly thinking, very difficult to think about. But Well, let's think about the cos angle formulas. We know cos of 2a is going to be essentially cos of a plus a. And then we can separate that into cos a minus sin a, or cos squared a minus sin squared a. Now there's a few other ways you can write this out, can't you? Because you can replace cos squared with 1 minus sin squared. When you replace cos squared with 1 minus sin squared, that becomes 1 minus sin squared, take away sin squared, so that becomes 1 minus 2 sin squared. Okay. Alternatively, you can replace sin squared with 1 minus cos squared. When you do that, you get cos squared, take away 1, but then the minus and the minus here make a plus. So this becomes cos squared a plus cos squared a, which is 2 cos squared a, but then minus 1. Okay, what we want to replace is cos theta somehow. Now, how we do that is, well, I think it's best to choose, well, first of all, cos of a theta. If we replace angle 2a with theta, then on the right hand side, this angle would be a half of theta, wouldn't it? Because what we see is a common trend is that the right hand side, the angle is always half the angle on the left hand side. That's one thing to note. On top of that, I'd recommend replacing it with this expression, and I'll show you why. So 1 minus 2 sine squared, half the angle on the left hand side, so that's theta over 2. If you replace it like so replace all of this with what I just introduced, 1 minus, sorry if it's getting a little bit messy. You can rewind, by the way, at any point. I wouldn't hold you to it if you do. It's really difficult. 2 sine squared of a half theta. The reason I chose a 1 at the beginning is because, like I said, the 1 cancels out with this one, leaving you with no constants on the denominator, which is what we want. Okay, so let's now simplify. We've already established that the numerator goes to 2 sine a half theta cos a half theta. This denominator will 1 take away 1 cancels out, and then minus 2 sine squared of a half theta. You can now cancel out the 2's. You can cancel out 1 power of sine of a half theta, leaving you with cos half theta over sine of a half theta, which is 1 over tan of a half theta, which is cot of a half theta. That was very difficult, wasn't it? Yeah, I think probably up there with one of the most difficult A-star level, A-level math questions I've done, at least. And it doesn't stop there, unfortunately. So yeah, let's break this down. It wants you to find all the y coordinates where d squared y over dx squared equals 0. So that's what essentially the left hand side is what you get when you differentiate dy dx. So let's start by finding dy dx so that we can differentiate it. So again, we're going to form the expression that is dy by d theta multiplied by d theta by dx. Let's now break down each of these individual parts. Dy by d theta is what you get when you differentiate this equation here, the right hand side with respect to theta. So cos differentiates to minus sine, so this will differentiate to positive over half sine theta. Let's write that out, half sine theta. Now d theta by dx, we have to sort of find dx by d theta, because that's something that we can find by differentiating the right hand side with respect to theta. And after we find that, we do the reciprocal to find d theta by dx, just like we did before. So the differential of theta, do be careful about that. I saw some students miss that out. The differential of sine is cos, so it becomes 1 minus a half cos theta. I don't really like this because it's a mixture, because you have to take the reciprocal of it. What I'm going to do is I'm going to make the 1 so that it's 2 over 2 minus a half cos theta, or minus cos theta over 2. And that will make it so that you can combine the numerators together. That's the only reason why I chose a denominator of 2. I think this is going to help later because what we want is a reciprocal of this, right? Which is the reciprocal of this. It's a lot easier to take the reciprocal of this function that I've now formed rather than this one here, if you get what I mean. So if dx by d theta is equal to all of this, then d theta by dx would be, like I said, 2 over 2 minus cos theta. So, sorry, 2 minus cos theta. In an exam, if something looks a bit more difficult to do, maybe you can rearrange it just like I've done here, because it'll save a lot of time, honestly. When you now multiply these functions together, the 2 cancels out diagonally, and we're left with sine theta over 2 minus cos theta. So we now have our expression for dy dx. Okay, that was fairly difficult, but if you're on the A-star level questions, it's not too difficult for you. Next is where it gets really difficult. you have to now differentiate this dy dx with respect to x. But the thing is, there is no term with respect to x here. So what do? What makes this question so unique? We do still have to use dy dx. And let's write out d squared y over dx squared. Let's think about how. The only thing we can do is differentiate this with respect to theta. So what we can do is you can split this up and say it's the differential of what we have, dy dx, with respect to theta. And then you can think, okay, well, how do I go from here to here? Well, we already have d squared y. When you do d times dy, it gets you d squared y. On the denominator, we have d theta by dx. What we need to multiply by is d theta on the numerator, so that it cancels out with this d theta, but also dx on the denominator, so that we get dx squared on the denominator. Hopefully that makes sense to you guys. So just to repeat what I did, I realized that dy dx, it can only be differentiated with respect to theta. So I found d by d theta of dy dx. But then we want to get to this expression here. So you need to cancel out the d theta by including on the numerator on what you're multiplying by. And also we need a dx squared in the denominator, which is where this comes in. So what that means is we're going to differentiate this term here, sine theta over 2 minus cos theta with respect to theta, which we can do because all the terms are with respect to theta, apart from the 2, but you can deal with that. Multiply by d theta by dx, which we've already introduced as 2 over 2 minus cos theta. Okay, nearly there, guys. So to differentiate a term where one is divided by the other, that's where we use the quotient rule. So I'm sure if you're watching this video, you know how to use it, but I'll just very quickly remind you. So if y is equal to u over v, we say dy by dx is equal to v du dx. Hopefully you can tell between my u's and v's. Minus u dv dx all over v squared. Okay, so we're going to call the upper function u. So u is equal to sine theta. We're going to call the function in the denominator v. V is equal to 2 minus cos theta. Du by d theta is the differential of sine, which is cos. Dv by d theta. Sorry for making you do such a difficult question. But when you differentiate cos, it's minus sine. So when you differentiate minus cos, it's positive sine. Okay, so v times du, in this case, it's du d theta, by the way, because we are differentiating with respect to theta, aren't we? So 2 minus cos u all multiplied by cos theta becomes, well, let's write out in terms of multiplication, because something might cancel out. So cos theta, 2 minus cos theta, minus u dv d theta. So sine theta is sine squared theta, all over v squared, which is the square of 2 minus cos theta. And then all multiplied by this expression here, d theta by dx, 2 over 2 minus cos squared, 2 minus cos theta, sorry. Okay, let's see where we can go from here. Okay, so I didn't go this far in my working out, but where you would go from here is, well, let's think about what we want is where d squared y over dx squared is equal to 0. So we want where this expression is equal to 0. A fraction is only equal to 0 when the numerator itself is equal to 0. You can't ever divide by 0. So like 4 divided by 0, that's non-existent. So we need the numerator to equal 0 in order for the left-hand side to equal 0. So we can say that this is true when the numerator, which is 2 cos theta, so I'm multiplying 2 onto each individual term. So 2 cos theta and then 2 minus cos theta minus sine squared theta is all equal to 0. That's when d squared y over dx squared equals 0. I'm assuming from there, to find the y coordinates where this is true, we want to solve this equation for theta, and after you've done that, you put it into the equation for y, and you get the y coordinate for which it's true. So let's do that. 2 cos theta times 2 is 4 cos theta. 2 cos theta times minus cos theta is minus 2 cos squared theta. And it seems like you want to replace sine squared with 1 minus cos squared, using the identity sine squared plus cos squared equals 1, because then everything will be in terms of cos, and it's easier to solve. Way easier to solve, at least. Okay, let's expand out. So minus times 1 is minus 1, minus cos squared is plus cos squared theta. Let's simplify that even more. So minus 2 cos squared plus cos squared is minus 1 cos squared, plus 4 cos theta minus 1 is all equal to 0. To solve this, I'm going to multiply everything by minus 1, because I think I don't like it when there's like a negative in front of the square term, if that makes sense. And so cos theta plus 1 equals 0. From there, you can honestly use the quadratic formula, which I'm just going to very quickly do. You can skip ahead a few, around 30 seconds if you like. So that's 4 plus or minus square root of b squared minus 4ac all over 2a. Okay, so one solution I got is cos theta equals 2 minus root 3. I'm just going to very quickly check, but I think the other one should be 2 plus root 3. Yeah, 2 plus root 3. Okay, let's think about these. Are these both valid solutions? This one actually is not, because cos, we know the maximum value that I can have is, if we briefly draw, that's a horrible graph. The cos graph, still bad, but sorry. The maximum value is 1 and the minimum value is minus 1. This goes way above 1, so that's has no solutions. Whereas this one, 2 minus root 3, if I just quickly check, I think it's in between minus 1 and 0, right? Yep. Oh, sorry, it's 0.27. So the fact that this is equal to 0.27 means that because it's between minus 1 and 1, this would give valid solutions. Now that we've got cos theta equals 2 minus root 3, we know that that is what's true when d squared y over dx squared is equal to 0. From there, you don't even need to honestly find the value of theta. You can just input it directly as cos theta. So we get y equals 1 minus a half of 2 minus root 3, which we're going to replace cos theta with. And you can even leave this exact form, actually. It doesn't want you to, but you can. So let's do that. Minus a half times 2 is minus 1. Minus a half times minus root 3 is positive root 3 over 2. 1 minus 1 is 0, leaving you with the final answer of root 3 over 2. And that's it. That's the very, very difficult answer to this very, very difficult question. Yeah, a lot of working out done here. I do have a few more questions like this. I have an A-star playlist, but this is definitely on the upper echelon, probably as difficult as it gets, honestly. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.